Now that we have understood what a black hole is, how its masses are properly how behaving, let us try and understand how the black hole itself behaves now as a unit. We had said that where there is a black hole, now there once was a star. So every star, that this is the galaxy that you see, this is the inner ring, this is the bar, this is the spiral arm. I have depicted the same thing. This is only a sectorial view. This is the inner ring, these are the spiral arms. So every star that you see here, if it meets the Chandrasekhar limit, has the possibility to convert itself into a black hole. Any star. So it is not just necessary that you should find the black hole only at the center. You could have the black hole anywhere in the galaxy. Wherever it meets the limit of Chandrasekhar, it could turn into a black hole. And what happens to that black hole? And we know that black hole is nothing but mass. Star is also a mass, black hole is also a mass. So why should why should universe treat black hole any differently? It just treats it like a mass that is tightly packed. So the black hole, if let us assume this one particular black hole is formed, it follows the same route as its parent star would go. So it would also go around the center, keep going around the center. But we also know that black holes feed, they bulk up. Agreed, we have minimum requirement of 2 suns, the core mass of the star which is collapsing. But we have seen that the black holes are many hundreds, thousands of suns. So how is it that it is able to bulk up? Especially when it turns black hole, the immediate meal that it has is possibly the planets near to it or its own planetary system, the gas around it, at the max a companion star or a binary star. Apart from that, the closest meal that it has is many light years away. The closest that Sun has as a star is Alpha Centauri, that is around 4 light years away. So it would be very difficult for black hole to bulk up, but for sure we know that it is it is bulking up. So that means there is something that is happening that is making the black hole either speed up or slow down. You either have to go and catch the meal which is in front of you, or slow down and catch the meal which is coming towards you. But why should black hole have this luxury when it is just a mass like star? Star doesn't have the luxury of speeding up or slowing down. So why should black hole have? This is where the Manthan model, the spacity model comes into picture. So in Manthan, the spacity model, whenever you have a system of masses which is more than 2, 3 or more, and they are in an orbit, they are subjected to a force called S3, which is acting in the general direction of the movement of the mass. Now what happens is, let us assume that one of these stars has one black hole. So most probably the black hole mass is less than the mass of the parent star. So this is what it is. And then there is something called as average orbital mass. So we see these stars, I have shown them as all similar stars of same shape or size, but that need not be. Some star could be smaller, some star could be bigger. So there would be an average orbital mass. If the black hole which is created, if that is more than the average orbital mass, then the S3 will not be able to move the new black hole just to the same extent that it was moving the parental mass. But since the black hole mass now is less than the average orbital mass, then this S3 would speed it up. S3 is general and it is common to all, irrespective of what the mass is. S3 is directly proportional to the average orbital mass. Now what happens is, this is giving the black hole a chance to either speed up or slow down. So that is how it either consumes the star in front or consumes the star in the one which is lagging it. But imagine, take it a little further, let this thing run around for 1,000,000 years. The black hole which is eating these two up, it would eat all of them. So what would happen is, if there is a black hole forming in this orbit, over millions of years it would clear this up. You should be able to see, just the way you see Saturn's rings, you should be able to see the rings in the galaxy, and we see that that doesn't happen. That means the black hole is not staying in the same orbit. It is moving out of that orbit. Now, what are the options for the black hole to move out? Either it has to move to its left or to its right. When I say right, it is moving away from the center of the galaxy. When it is moving left, it is moving towards the center of the galaxy. Where would it move? In or out? For that, we need to understand what is a galactic gradient. What you see here is a top view of a galaxy, and this is shown as though all the constituent masses are in the same plane. It is not so. If you take an elevation or a cross section, this is the supermassive black hole. The black hole which is formed here or here is not exactly at the average plane. Even if it is a few millimeters away from this, that is good enough for a gradient to form. And this gradient, imagine if this black hole has to negotiate this gradient. If it wants to move out, it is like climbing up the gradient, climbing up the slope. And this black hole doesn't have the energy to climb up. Unless until you have energy, you cannot climb up. And it is not just the black hole on this side. Even if it is on the negative side of the black hole, even moving out would be climbing up the slope, because there is no up and down in absolute space. Just the way this finds difficult to climb up, even this would find difficult to climb up, and the only way for them is to climb down or move towards the center. Now, what happens when it is moving towards the center? Let us assume the black hole that we are considering was in the 4th orbit, that has moved to the 3rd orbit. Obviously, when it moved from 4th to 3rd, the average orbital mass was more than the black hole, less than the black hole mass. That is why it moved down. When it could not survive the 4th orbit, it will not survive even the 3rd orbit also, the next orbit. And if the same thing happens to the 3rd orbit also, in the same way it keeps sliding down. Once it moves out of this orbit, it is downhill all the way till it reaches the supermassive black hole at the center. That is how the black hole which is there at the center becomes a supermassive black hole to the extent of 4 million suns. You do not see a black hole which is 4 million suns somewhere in the inner ring. You will see that supermassive black hole only here. That is because every black hole which is formed here in the galactic rings, whether it is inner ring or the spiral arms, everything slides towards the sink of the galaxy and creates the supermassive black hole. Now there could be, and that is why you see black holes near the supermassive black hole. It's not necessarily at the center, which means that it is still on its way to, in a few million years, it would reach the center. And what would be the path taken by the black hole from where it generated till it reaches the center? It could be straight down, it could be lunging forward, or it could be lagging backward. It all depends on where it was, what was its mass, which orbit it is moving, what was in its vicinity. Accordingly, the path would be decided. And these are basically the travel habits of as proposed by Manthan.